Welcome to Tomorrow Unveiled, your destination for cutting through the noise and diving deep into the most significant breakthroughs shaping our future. This week, we're embarking on a really exciting exploration of what's happening in the world of AI. We're calling it AI Unveiled. Our mission, as always, is to bring you the most important nuggets of knowledge and insight, directly from the latest research and analyses. And what's truly striking in the research we've been looking at this week is this kind of fundamental shift in the AI landscape. It really feels like AI is evolving beyond just being a powerful analytical tool, crunching numbers or predicting patterns. Instead, we're seeing it emerge as this, well, truly autonomous, creative force, maybe even a co-pilot, driving discovery and efficiency in ways we couldn't have imagined before. It's not just a technical tweak, it feels like it's redefining what intelligence means in this digital age.
Absolutely. Yeah, the reports really do indicate a real maturation in the field. We seem to be moving away from what was for a while mostly about just scaling up bigger and bigger general purpose models. The innovation frontier now, it's demonstrably shifting towards these highly specialized, incredibly efficient architectures, ones designed for specific high-stakes value applications. So in this exploration, we'll dive into, I think, three core areas where you really see this shift. First, AI taking on the role of a true scientific pioneer. Second, those groundbreaking architectural innovations making AI smarter and, importantly, leaner. And finally, the critical challenges we need to navigate as these powerful new technologies emerge.
Okay, let's unpack that first point then. AI as a scientific pioneer. When I hear that, I think beyond just number crunching. I'm imagining AI generating genuinely new knowledge. And some of the findings our research team flagged are, well, literally out of this world.
Yeah, one particularly compelling development is the NASA IBM Suria model. It's a first-of-its-kind heliophysics foundation model.
Heliophysics, so sun physics.
Exactly. And consistent reporting across multiple sources shows this AI was trained on, get this, 9 years of high-resolution solar data from NASA's Solar Dynamics Observatory.
9 years, wow.
Yeah. Now, what's a foundation model here? You can think of it as this vast pre-trained base that really understands a specific domain, in this case, solar physics, and that lets it tackle new, related tasks more easily. Suria can forecast solar flares up to 2 hours in advance.
2 hours, that's significant lead time.
It is, and with a 16% increase in accuracy over the previous methods, the broader implication here is just immense. Accurate space weather forecasting is absolutely crucial for protecting our tech infrastructure here on Earth. We're talking satellites, GPS systems, even our power grids.
Right, things we completely rely on.
Exactly. And the fact that Suria is open source is also a big deal. It democratizes access to this vital forecasting capability, for the broader global community.
That's incredible. Basically a weather forecast for space, giving us critical warning. Amazing. But AI's ambition isn't just looking up at the cosmos, right? Our sources also show some groundbreaking work in medicine. AI diving deep into the microscopic world, hinting at real changes in how we fight disease.
Right, and this brings up a really important aspect of AI's capabilities, de novo creation.
De novo, meaning?
Meaning creating something entirely new, completely from scratch. We saw compelling reports detailing how generative AI, specifically from an MIT team, successfully designed entirely new antibiotic compounds. They're designated NG1 and DN1. And these compounds showed significant efficacy against really nasty drug-resistant superbugs like MRSA and Neisseria gonorrhea, at least in lab and mouse models so far.
So this isn't just sifting through existing drugs.
No, exactly. It's not just screening existing drugs from some vast library. This is AI exploring an immense, previously uncharted chemical space, basically, to design molecules from first principles. It's a fundamental shift, really. It offers a tangible new pathway to tackle the escalating global crisis of antimicrobial resistance.
Which is a huge problem.
A massive problem, responsible for millions of deaths every year.
So AI generating solutions to these massive human problems, solar storms, superbugs, it's a powerful vision, really inspiring. But okay, for all this incredible potential, what are the practical hurdles? Are the sources highlighting things that might temper some of that excitement?
Well, yeah, that's precisely where what researchers are calling the synthesis gap comes in. It's a really good point.
The synthesis gap.
Yeah. So while AI can indeed design millions of theoretical molecules with incredible speed, the real-world challenge, the bottleneck, often lies in actually physically creating these complex, novel structures in a lab.
Ah, okay. Making them real.
Exactly. The research noted that in one study, out of 80 promising AI-designed antibiotic candidates, only 2 could actually be successfully synthesized.
Only 2 out of 80. Wow.
Yeah, a stark 2.5% success rate in that case. It highlights that real-world applications still needs significant human ingenuity and advanced chemical synthesis techniques. We need to bridge that gap between the computational design and the physical reality. It's a reminder that even with these breakthroughs, the journey to real-world impact is definitely a collaborative one.
It's a very stark reminder, isn't it? That even with these incredible computational leaps, human ingenuity and the messy reality of the lab are still absolutely indispensable. It really underscores that human-in-the-loop aspect. Okay, so we've seen AI pushing the frontiers of scientific discovery. But how is AI itself evolving to handle these ambitious new roles? Let's pivot now to those fascinating architectural innovations making these systems smarter and leaner.
Yeah, a key insight emerges here with the rise of what you might call hybrid thinking architectures.
Yeah.
A good example is DeepSeek v3.1. It's an open source model that uses a mixture of experts, or MOE architecture.
Mixture of experts.
Yeah.
Okay, what does that mean practically?
Think of MOE like having a team of specialized mini-brains inside the AI. Each one is really good at a particular type of task, rather than having one giant general brain trying to do everything.
Right, okay.
And the key innovation with DeepSeek is this prompt-controlled hybrid thinking mode. This means you can essentially tell the AI, okay, for this query, just give me a quick answer, or for this complex task like coding or math, engage your more deliberative, computationally intensive thinking mode.
Ah, so you can tailor its effort level.
Precisely. It directly addresses that long-standing trade-off between speed, cost, and reasoning depth. It makes these powerful AI agents much more practical and, importantly, economically viable.
So it's like having an adjustable brain for the AI, depending on what you need it to do. That's incredibly clever. It hints at a future of much more dynamic and responsive AI. What other advancements are making AI more accessible and efficient?
Well, the broader implication here is a clear industry trend toward what the research team that compiled this information called smart scale. It's not just about bigger is better anymore.
Smart scale, I like that.
Yeah. Consider Google's Sparse Former, for instance. It tackles the huge memory challenge you get with large models by using sparse attention mechanisms.
Sparse attention.
Imagine an AI that doesn't need to look at every single piece of data all at once to understand a complex question. Instead, it intelligently focuses only on the most crucial parts, a bit like how our human minds filter out distractions.
Right, more focused.
Exactly. And this drastically reduces the computational load. It makes large models faster to train and run, often without sacrificing accuracy. And similarly, you have advancements in specialized AI hardware, like NVIDIA's new Blackwell GPU architecture, that are really underpinning these architectural improvements. This relentless focus on efficiency means powerful AI capabilities are becoming more accessible. It allows smaller labs, smaller organizations, not just the tech giants, to start tackling high-performance models.
Which sort of democratizes the whole field.
It really does. It democratizes AI development and fosters much wider participation.
Okay, so AI is getting smarter, leaner, more accessible. But as it unveils these incredible new capabilities, it also brings into sharp focus some significant challenges, some considerations that we as a society absolutely need to address. What are some of the critical, ethical, practical, even geopolitical issues the sources were highlighting?
Yeah, that's crucial. How do we ensure these incredibly powerful systems are deployed responsibly and safely? That's the big question. The research points to global efforts. You see the EU passing its new AI Safety and Transparency Act, which imposes pretty strict rules on high-risk AI systems.
Right.
And there's also, interestingly, overwhelming public support in the U.S. for stricter government oversight of AI. This includes things like mandates for disclosing training data, requiring rigorous risk assessments before deployment, and even banning deepfake content in political ads.
So a growing demand for guardrails.
Definitely. These efforts really highlight a collective insistence across different regions on responsible development and deployment.
And then there are maybe the more subtle but equally important questions around trust and just the practical realities of integrating AI into our daily workflows, into businesses. This is where the rubber meets the road, right?
Absolutely. And a key insight emerging here is something identified as the verification tax.
Verification tax. That sounds ominous.
It kind of is. Studies, including one from MIT, indicate a pretty sobering reality. Roughly 95% of business initiatives trying to integrate generative AI are currently failing to achieve meaningful returns on investment or productivity gains.
95%. Why so high?
Well, The primary reason seems to be that even advanced AI models can be confidently wrong.
Yeah.
They can make mistakes, but sound utterly sure of themselves.
Ah, okay. I've seen that.
Right. So this forces human employees to spend significant time double-checking, correcting, refining the AI outputs.
Hmm.
And that often erodes the very efficiency gains the AI was supposed to deliver in the first place.
So the cost of checking outweighs the benefit.
In many cases, yes. This crucial issue of reliability, transparency, and ultimately trust is paramount for successful, widespread AI adoption. It reminds us AI is a powerful tool, but it's definitely not a perfect one.
It certainly puts a dose of realism into some of the broader AI hype we often hear. And the geopolitical landscape adds another complex layer to all this, especially with the rise of powerful open source models coming from different parts of the world.
Absolutely. Yeah, and that's another layer, right? The open sourcing of powerful models by entities like DeepSeek, for example, introduces specific and, frankly, noteworthy risks. Independent security audits have revealed vulnerabilities to jailbreaking attacks.
Meaning you can trick them into saying things they shouldn't.
Essentially, yes. Leading to the potential generation of harmful or dangerous content, suggesting their safety filters might be less robust than some others. Furthermore, their data privacy policies, which indicate user data might be stored on servers subject to foreign national security laws, raise concerns. And there are observations of built-in censorship on certain politically sensitive topics.
Okay.
So this raises serious concerns, particularly for applications that require unbiased information or really strict data governance. What this means is organizations now have to perform careful geopolitical due diligence. They need to weigh the undeniable tech benefits and cost advantages against these inherent risks tied to a model's country of origin and its associated legal and political frameworks.
So it's not just about the tech anymore, it's about where it comes from and the strings attached.
Precisely.
So, pulling all this together, what does this all mean for us as we navigate this rapidly changing world? Our AI Unveiled analysis has shown us an AI landscape that's just evolving at an astounding pace. From AI taking on the role of a scientific pioneer designing new drugs, forecasting solar storms, to these ingenious new architectures making the systems more efficient, more accessible, the innovation is truly breathtaking.
Yeah, stepping back, you can see a clear trend towards what some are calling the AI scientist, AI becoming a creative partner in fundamental discovery.
Right.
We're also seeing this proliferation of highly specialized, domain-specific foundation models, like Suria for heliophysics. We'll likely see many more of those. And finally, there's this intense effort, almost an arms race, in developing truly agentic and efficient AI architecture systems that can perform complex tasks more autonomously. It points toward the future where AI isn't just bigger, but demonstrably smarter, more creative, and deeply integrated into, well, really diverse aspects of our lives. Think personalized medicine, enhanced enterprise automation, and much more.
It's clear we're entering an era where AI is not just everywhere, but it's also under an increasingly powerful microscope. We're collectively working to ensure these advancements actually benefit humanity. Perhaps the deepest question we face isn't just what AI can discover, but maybe how we, as humans, will redefine our own roles in a world where discovery itself is becoming automated and shared with machines. What does that mean for creativity, for human purpose, maybe for the very nature of intelligence in the future? Lots to think about there. And if you're finding this insightful, please do take a moment to like this video, subscribe to Tomorrow Unveiled, and be sure to turn on notifications so you never miss an update on the future. If you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It truly helps us reach new listeners, and we love hearing your thoughts. Whether you're on YouTube or your favorite podcast app, leave a comment and let us know what you think about AI moving into scientific discovery and all the challenges and opportunities it brings.